we're going to determine the formula weight of a number of compounds, which is done simply by adding up the atomic mass of every atom involved in one unit of that compound. You want to make sure that you have your periodic table handy, because that's where we get those atomic mass values. Looking at calcium sulfate, we see we have contributions from calcium, one atom weighing 40.08 grams per mole. Again, this value is obtained from the periodic table. Sulfur, one atom of sulfur, contributing 32.07 grams per mole. And for oxygen, we have 4 atoms of oxygen, each weighing in at 16 grams per mole, for a total of 64.00 grams per mole from oxygen. We add these together to get the formula weight, and here it's 136.15 units are grams per mole. The next compound is water. We see from the formula that there are 2 atoms of hydrogen and 1 atom of oxygen for each unit of this compound. So we need to add the mass of hydrogen to that of oxygen. So we have a total mass of 18.02 units being grams per mole. Again, all we're doing is adding up the atomic mass of each atom involved in one unit. Some more practice. Here we have sulfuric acid. There's hydrogen and sulfur. Here is a slight glitch. Some periodic tables will give the atomic weight of sulfur as 32.07, sometimes as 32.06. Don't let that throw you. Just use the value that you have on the periodic table we give you, and you'll be fine. We also have oxygen, 4 of those. So we get 64 total from the oxygen, 32.06 from the sulfur, and 2.02 from the hydrogen. So we have a total of 96.08 grams per mole. Now we are doing a lot of these, and it does seem tedious, and it can get tedious, but it's very important that you practice that skill so that you can quickly and accurately determine the formula weight of different compounds, even complicated looking ones like DDT. So for carbon, we have 14 atoms of carbon, each contributing 12.01 grams. So we have a total of 168.14 grams from carbon. Hydrogen, we have 9 of those. Each contributes 1.02 grams per mole. So that's 9.09 from hydrogen. And for the chlorine, 5, each coming in at 35.45. 5 times 35.45 comes out to be 177.25. We add all these values up for our formula weight of 354.48 grams per mole. And you want to get into the habit of using 2 decimal places when you calculate formula weight, as most often that's going to give you enough sig figs for your answer. Glycine has contributions from carbon. Hydrogen. Nitrogen. And oxygen. We add all of these up and we get a formula weight of 75.08 grams per mole. Formula weight of sucrose is determined by adding up the atomic weight of each atom. We see that there are 12 carbon atoms, each weighing 12.01. Again, we get the 12.01 from the periodic table, and the 12 comes from the subscript because that's how many carbon atoms there are in this unit. All right, so this value is 144.12. For hydrogen, 22 atoms, each 101 grams per mole. A total contribution from hydrogen of 22.22 grams per mole. Oxygen, 11, each at 16 grams per mole, a total of 176. So we have a total formula weight of sucrose, 342.34 grams per mole. This next compound is an ionic compound, aluminum sulfate, and you may find it easier for you, at least at the start until you've practiced these, to rewrite this showing that there's 3 sulfates. So there's 3 of these entire units. So there's 3 sulfurs and 3 times 4, 12 oxygens. So you may find it useful to rewrite the formula as Al2S3O12. Let me go through our process as usual. 2 aluminums, three sulfurs, and 12 oxygens. So we have a total formula weight of aluminum sulfate, 342.17 grams per mole. And finally, glucose from carbon, 6 atoms. Hydrogen, 12 atoms. And oxygen has 6. So we have a total of 180.18 grams per mole.